Okay, so let's figure out what we want to do here. No, I want to see what we have, because we have this slice here, and I don't know what this is. So let's do got header length needed 5. Let's see what you are. Okay, we got letter header length 438. That's different. Huh. Now why? Now let's say I took you, so I want this to be just the bytes, right? So then you're going to be bytes essentially. Import bytes, bytes. All of these tests are now going to be super unhappy. We need to now do this as I think we create use a new bytes, and then we do header. I have to add into it. There's concat. It's not helpful. Oh, can I just be? Oh, I might be able to. I didn't even try that. Let's try that. Also, I don't need. Hold on. Let's do this properly. So we have B for you. Okay, expected. If I do header into the trait bound bytes from that is not satisfied. They implemented off of a box. Really? Or a vector. Or, oh, a static string. Interesting. So I could do that. Oh, and this would just be empty, right? But that should still work. Okay, so if we do this, you don't need to be mutable anymore, because I'm not using you in that way. So our test should still work. They do, okay. And if I do cargo run, okay, so we got header length. Okay, so now if we get these bytes like that, I want to grab maybe the first one. So I think it created a slice of cell with a I'm so confused about what's going on with these slices. So this returns a new bytes. This will increment the reference count for the underlying memory and return a new bytes handle to set the slice. Assert equal that a reference of B of everything is LLO. Oh, wait, I did this wrong. Oh, wait. Okay, wait. You're going to be fine. Oh, I did split off. So I want slice. Slice of 0 to 5. Okay, that works. Now I want to, so that was slice. Now they have split. Splits the bytes into 2 at the given index. And okay, so self contains elements 0 at, and the return bytes contains elements at length. Okay, so I would need to do split off on 2 different things, or split 2. Okay, so basically this mutates the original one and creates a new one. So it basically creates 2. And then slice gives me the actual things that I'm looking for. So if we do slice again, and then let's try printing it out. So let's do our let's start with 5, right? I guess we'll start with 0 to like 50. Okay, so we get the beginning here. So that's that 001E hash space service. Oh, it's not enough. It's not enough. Okay. So then we need to go significantly further. Let's go to 100. Then that gets me, okay, so not too far off. So if I start here and I want, let's say the beginning of, let's see, so this is like what? 1, 2, 3, 4. Starting, okay, so 0. So if I want to start at 38, so that's starting at 38, not ending. So if you start at 38, and I go to 100, let's say. Now the 100 is still wrong, but I want to see if I start at the 23F. Okay, so this is the beginning of our hash. And then the end of the hash that we're interested in here is going to be 20, right? Oh, is it every 2 of these is 20 is 1? So it's like 1. I think it's 20, right? So oh. 58, 59. That doesn't seem to be enough of it. So 40 maybe. So 79. Okay, so that gets me to BBB. Oh, 40 hex encoded bits. Okay, okay. So that makes sense. This gives me to the BBB there. Oh, and I have an extra space at the end, so I want to go there like that. Okay, so this is now the hash that I'm interested in. What do I want to do with that? Well, I want to grab all these hashes out and have them in a vector. Now, if we cheat, which we are right now, then we're only getting the hash for this very specific repo, because we're just like counting in there. What I really should do is I should create another reader and then iter through all the bytes and see like, okay, what state are we in? Are we in the hash? And we need to capture that out. That would be the best thing to do, and sort of like grab what we're interested in, which I think is, I mean, that's what we're supposed to be doing. So let's not cheat. We'll do that. So how do I want to do this? This is going to have to be a struct, isn't it? So if I have a struct, and we're going to call this the discovery. So the ref discovery. And inside of here, we can have our header. Do we want all of these to be the bytes that we're just sort of grabbing out? And I can just say this is going to be a vec of view 8? Or do I want them all to be bytes? I could have them all be bytes. I don't know if that, actually don't know if I care about the header in here. What do I really care about here? We could, okay, let's do that. Let's do it. Let's, we'll have our header. Should this be bytes? Maybe it should be. We have our bytes. We have the service. Should I turn that into a string so we can see what it is? Maybe. Then we have this null that we get to. Then we have a mode. Okay, so we're going to care about one of these, which this almost looks like it's its own struct, doesn't it? Because it has a mode, it has a hash, and it has the pointer. I guess the branch. That would make sense. I'm actually kind of curious. What would happen? Let's point this at something that's not a single branch repo. are there any good non-single branch repos? One that has a few, but not too many. Like, okay, Express CRUD only has one. Our learning game design patterns has two. That might be good. Okay, so let's replace. Okay, so we put you in there like that. Okay, so if we send you. Oh, this is way more than two. Okay, so it's. All right, so we get our service get upload, we get you. So we get our 4 zeros, we get our mode. Oh, 7 branches, 2 are from forks. Okay. You're right, that is 7 branches. I thought that this was branches. No, those are forks. Oh, okay. I thought these are pull requests. Oh, okay. That's what it was. I misread what the designs are. So this actually doesn't show me the number of branches in here. Okay, whatever. This is fine. Seven branches. So we have our head. So on our head that we can see goes to master. Groovy, hello. How are you doing today? What is the program you're using for the request called? So here, this thing that I'm using is called Insomnia, which I want to say is a Mac only, but I'm not sure. But yeah, so it's Insomnia. I'm not really like sold on any of these right now. They keep on trying to move into cloud-based and just like go the same direction that Postman is, which is the reason why I keep on switching away from Postman. So Arch, you're having a weird issue with your web server where if SSL is enabled and someone goes to HTTP on that port, the SSL handshake data that was sent is displayed on the web page. Oh, that is weird. I've never heard of that. That doesn't sound good at all. Yeah, so if you like, all of these sort of follow the same pattern. Insomnia, Rapid API are the two that we have here. I don't remember if they're Mac only. Rapid API is Mac only. Insomnia, I don't remember one way or the other. If you have VS Code, Thunder Client is great. That has not yet turned to the dark side to go like cloud featured yet. So that's also a good choice. And then I would imagine that somebody has created something for CLI that basically just does this in CLI format with like a nice little graphical image. If not, that somebody should make that. Just like a thin client on top, a thin wrapper around curl to make it look nicer. That would be great. You're on Linux, you have Windows and a second drive, but you notice you bother turn on. I pretty much only use Windows for the actual streaming and gaming right now. That's pretty much all I have it for. The rest I'm on, I'm over here on Macland. So yeah, I'm with you on the not using Windows as much. Okay, so basically this always is the same. And then we have, so we have our null that ends the header. And then we have our mode. And then we have our hash. And then we have that it's okay. This is where we're currently pointed. This is where head is currently pointed at. Down here, we have this simref. Head is pointing towards master. Is this actually master branch? It is. Okay, so this is back in the old days. The old days when it was still master instead of main. And then we have our types. Oh, wait. Okay, so we have our filter object format, SHA-1, agent, get, GitHub. Okay, I thought that this and this were sort of together, but they're not. So this is a new SHA-sum, and then it's a branch pointing to refs heads attempting to make an editor. Okay. So then, okay, so these are all of the branches. These are all the branches. So we saw it was what, 7 branches. So this is oh, and then we have our commits. Interesting. Okay. So we have 1, 2, 3, 4, 5, 6. Okay, so this would be 1, then 2, 3, 4, 5, 6, 7 for all of our branches. And then we have all the commits for the main branch. So I don't get all the commits for the other branches. Is that right? Not from here. Yeah, gaming keeps getting better on Linux. The only thing that truly makes Windows necessary for me these days is the government, because they keep making Adobe Acrobat only PDF forms. Yeah, although you can get cloud Adobe readers these days. And that might work, right? Except they keep on making you, well, wait, can you write into Acrobat in the cloud one, in the cloud version, or is that read only? I don't remember anymore. It's been way too long. Okay, so this is super interesting. So basically, this is our header, and I literally just don't care about this, right? Like, we grab you out, and then we grab this out, and then we want for each ref. Okay, so we might have ref discovery, but we should start with just a ref, right? So ref has a mode, which is going to be a, that looks, let's just make it a string. So that would be 0115 here. Then we have our hash. It's going to be a string. And then we have the branch. And then we have the branch. So the branch name, and we'll just make that be a string. And then that repeats, right? And so that's what we want for all of these here. Oh, the signing ones, of course. Digital signing is it's surprisingly hard. There's a reason why DocuSign has essentially won that entire battle. Okay, so now, okay, so we have a ref here to get that. We're gonna need a as we go through this, we need to validate our header and to make sure that it has that, which we already do right now. And then I need to start iterating through each byte until we get to this. And then we start needing to say like, okay, give me the mode. Which we know that's going to be the next 4. And then get me 40. And then get me until a null. Okay, this is gonna be our main thing today, is grabbing all this stuff out of here. Okay, so I believe we're gonna want an enum for this, for our sort of like our reader state. We are going to be in the header. So we're either going to be in the header right here, which goes until that, or we're going to be in a mode. We could be in the hash. We can be in the branch name. We can be in the features, I think. And then that brings us right back down into here where we get another mode. No, it just gets us the .055. Is that okay? So this is attempting to make an editor. Okay. Oh, it's a tree, right? It's a tree. Can I see what the tree? I don't think I can do that there, but you know what we can do. If I take you, well, first of all, we can just count this, right? So it's like what? Oh yeah. Okay, so here's to 40. So this is the mode here. So we have another mode. So then it drops us into another mode, and then the hash, and then the branch name, and then mode hash branch name. Okay, so we go through that, and then here it's going to be another mode hash. That just continues down. But I want to say that these are commits, right? These are... I want to say those are commits. Okay, so taking back up to the master branch, and the most recent master branch commit is CB13B1D. Okay, here it is, CB13B1D. So yeah, so these are commits at this point in time, because that... Oh, that's also a commit here. Oh, that's the commit. I thought for some reason that would be the... Also, it's the commit, not the tree. Interesting. Okay. What is hopscotch? Is that a cloud? Okay, so those are, let's name this to commit hash. So we have a commit hash, the branch name. Okay, so reader state, we are in a motor. Okay, so we do all that stuff. Okay, so then we need to go through this. Oh, it's an open source Postman alternative. Interesting. But it's cloud-based, but you can self-host it. That's also pretty cool. Okay, so given this, what do I want to do? I want to start going through, okay, so we know oh, so okay, so we have our bytes. So we get these bytes, right? Oh, this is gonna be weird. So yeah, slice feels like it's gonna be better than splice or split. So we get our header out and we validate the header. I feel like we're gonna want to have maybe a struct of refs, or maybe this will just be end up being a vector of refs. So okay, so we get our header, we get our first. I don't want to get first ref like that. So once we get the header, we know we're starting at 5. I want to grab I want to iterate through all the bytes until we hit 0000. Okay. So let's create a function to, it's not going to be for each ref, is it? It's going to be for all of them. So let's create a function to iterate through the refs to process the input. Okay, so we have process response. Process this. Okay, this is going to be the ref discovery response. We're going to get the entire response, which is going to be a stir. No, I want it to be the bytes, don't I? So you're going to be the bytes. And we need to return probably a vector of ref. And I probably want to make this be a result with a vec of ref. Okay. How do I want to test this? So should extract one ref. Okay, so we have our header. I guess I want to turn this into the bytes, right? So let's do header. Let's do our response. It's gonna be equal to, I want to not grab this one. Let's grab the more basic one. Can I go backwards with this? No, okay, I can't like go back. Oh, but we can grab you. Okay. Now, I would like to do bytes from that, if possible. Yeah, okay, that works, except it's a little bit odd in the editor, but okay, so it's technically mostly one line. Oh, there is a return here. Okay, so you're all one line, so I probably need to do something like new line like that. There. That'll be better. I just downloaded it. You can use it as a PWA without noticing that it's a browser. You can export the browser's JSON response to REST struct. Really? That's pretty cool. But you always feel bad when I return okay. Why? Like, there's often times when we just want a result with nothing in it, right? So like in that case, just the okay like that makes sense, right? To me, this is doing some logic, whatever. I don't care about the response, so it's going to be mutating state somewhere else. And then this, if it reached down there, we're done and we're successful. So yeah, I do that whenever I don't need to return something, but I want to like mutate something or do something else with it. In this case, the tests never really return anything, so therefore that's kind of what I have to do. You don't want to put those new lines in. That's not going to match the actual response. Oh, multi-line strings? Okay, so never mind. Okay, we'll keep it like that. So you're okay there. Okay, so we have our mock response. We have our mock response. I want to actually get oh, and this totally makes sense. This makes a lot more sense looking at this now. This is the beginning of that second series of lines. That's the reason why this is repeated here, right? So 23F0 BC, it's repeated because this is where head is pointing, and this is the most recent commit for the master branch. Okay, that makes a lot of sense. And it's just a single commit. I guess it's just a single commit. You want to rewrite your website program? Would you try abstracting the loop of receiving and answering messages away? You do not like noticing that it's a loop. I think it depends, right? Like it might be worth it to throw it into like a struct for like handle it, or like run, or maybe just like a function somewhere that just like runs it. I think I'm not sure. It's been too long since I've written any WebSocket programs. My initial thought would be try it and see if you hate it. Right? Axum, for example, does not feel like a loop, right? I mean, that's very true. You probably do want to separate it out in some way that the logic that you're doing doesn't feel like it's inside of a loop, but it's rather being called by other things. or you're registering functions to be called later. That's kind of what we're trying to build in that kind of system. Okay, so let's see, back to here. Okay, so we have user mock response. I want to then grab out what? We already got past the header, so we know that this is a valid thing. We want to start processing it, and we want to get a list back. Oh, okay, so let's create like the ref. So the expected ref is going to be equal to a ref. My ref, not that ref. This ref is going to have the mode is going to be 0155. Let's put an impl on this. That'll make it a little bit easier. Why are you? Oh, because you still need. Okay. Oh. Wait, why? Where? Oh, because I have to do the entire. Nope, that's not what I wanted. I wanted after that. There we go. Finally got it. Okay, so now we can do ref new. Okay, so the mode we know is going to be 0155. The commit hash is going to be this, so to there. And then a branch name is going to be, do I want to just hand this entire thing out, or probably this? That's what I want to hand it in. Okay, so that gives us a ref now. And then our expected result. It's gonna be our expected ref, just one of them, right? We want our actual result. To be process ref discovery response. We're gonna pass in the mock response. Get that and assert equal result and the expected result. You're upset because you need to implement debug Okay, we need to implement partial, equal, and debug for ref. Okay, no more errors. So if I run the test, that's cargo run. That's not what I want. I want cargo test. Failed should extract one ref. We get you didn't tell me what was wrong. Interesting. I'm used to it saying, oh, not yet implemented. There it is. Because I put a to do in there. That's why. Okay, so now if I return back just like an empty vector, I guess it would be an okay with an empty vector. Now it'll tell me, okay, so empty array does not equal that ref. That's what we're now expecting to get out. Funny stuff is that WebSockets and Axum work exactly the same, so no reason to use Axum. Oh, interesting. Is that true? I guess that does make sense. Because they do run on their own branch. Oh, sorry, their own port. They're basically HTTP. Yeah, I can see that. I think I used WebSockets in Rust once, and that was with Tungstenite, which I believe is another project from the Tokyo team. Is that still the library to use with WebSockets? It's been a long time since we've looked at it. Hyper Tungstenite. Okay. Good to know. All right, so now we can write this, and we will know if we successfully do it. And in fact, we can do this really quickly. We can start, we can set up a watch for this. We can do cargo watch, run the command test. Oh, it's exec. Okay. No, is it exec? It's not C, it's X. And then I want test. Okay. So this is a really cool pattern. I don't know if any of you, I think I've showed this before. This is, I don't know if fully this is considered an exploratory test, but it's, I think the idea is there. I have my tests. I could actually, you know what? We can do even one more. We can do one better. If I test and then pass it the name of the test, what process ref. Do I not need to give it? How do I do cargo test? Okay, yeah, that tests. Oh, that runs 0 tests. How do I give it the specific name of the test that I want to run? It didn't run any tests up here. Oh, I was looking at this. Yeah. Haha. Yeah. I was giving the name of the function that I'm testing, not the name of the test. Okay, so we're testing that one, and so I want to now do a cargo watch x test that. And then I need to make sure that you go into the test. Oh, that doesn't, okay, that doesn't work. No. Oh, this just needs to be quoted, maybe? That's it. Okay, so now every time I make a change to this file, it's going to rerun the tests, but specifically that one test. So now I can just write this this function out, and as soon as it's working, we could just get what we expect out of it. So that's good. That's pretty awesome. And I enjoy that. Okay, we have a test coming up, an ad coming up in 1 minute. But I think we'll just keep on working through this. All right, so how do I want to do this? I want to take on a response, and we want to start. Oh, Albert, 10 minutes ago, you submitted we ran out of pretzels. I wonder if I can make it have a sound when that happens, so I can see the request coming in a little bit more. But you're right, we did run out of pretzels. Let's restart that. Coffee drinker, hello. How are you doing today? There you go. I refilled the pretzel jar. Just had a nap. Not bad. Excellent. Excellent. Unfortunately, ads are starting in 5 seconds, so I guess I'll see you on the other side of that. Oh wait, no. Coffee, you're a subscriber, so you won't get that. I don't think that subscribers ever get advertisements, or at least they shouldn't get advertisements. I certainly don't turn on the feature to like force subscribers to get that too. Okay, so what did we want to do here? Okay, so I want to start looping through all the bytes. So let's just one thing at a time, right? Let's for our byte, which might be a weird thing. So let's do 4b in response dot. Can I get that here? That kind of works. Okay, so that gives me a U8. Okay, so it implements an iterator for that. Yeah, ad free is always nice. Okay, so 4b in response. Okay, so I could just print out what this is, right? And let's do that. Let's debug B. And okay, so we see our debug printing out. Nice. So we see each of these bytes coming in. So okay, this 48. This is that not that? Those first two are the exact same. Oh wait, no. I'm passing in this. Oh, okay. I'm passing everything here. What I probably want to do is get a slice here and ignore the first 5. So 5 through the end. So here we have 001 E hash. Okay, so 35 is the hash. So I want to start at 5 and go to the end. So result. So let's get a slice of 5 to the end. Okay, so this time we start with 32, which the previous time we started with 48, 48. So 0, 1, 2, 3, 4, 5. Okay. So 32 is right. Okay, so 32 starts with that space. So we're starting here. So we're in the header still. I guess it doesn't actually matter where we are. We're in the header and we're in there until we see 4 zeros in a row. Oh, that's fun. Oh, if I get 4 zeros in a row, I kind of want to split at 4 zeros, don't I? Let's try split at 4 zeros. So this is, we have the head. Oh wait, no, the original. Okay. I wonder if we need it. Oh, we probably need to clone you, right? So this is gonna be our response. Can I 2 own to this? Okay, so we get ownership of the header. I need to make you mutable. We're going to let our, so we're going to have header on one side and we're going to have the rest of this here on the other side. So I want to split at the first one of these, right? So this is going to be, I guess, like the main body. These are going to be the hashes. So, I mean, the body, the header dot, we're going to split. To at the given index. Oh, but no. Okay, so wait a second. Split n returns an iterator over subslices separated by elements that match pred. Okay, this is what I want. And okay, so n is usize. Returns an iterator over subslices separated by elements that match pred, limited to returning at most n items. So give me 2 items. And then we have our function. This is going to be a bytes. And then we want this to be something that implements, this returns a Boolean. And if we keep it, if it's true, it splits at it. So I want the, oh, but this is each individual byte. Oh no, that's not right. Oh, that's not great. Okay. That's not gonna work. I need a way to find 0000. There's no find in here. We can do an iterator. Okay, can I do iter as opposed to into iterator? It's not helpful. So there's no find, there's no search. Okay, so this is gonna suck because that means I have to count